Hi, it's Ms. Reese. We're going over the congruent triangle Edpuzzle here. So first question, we want to use the given information. We're going to add that to our diagram, and we're going to determine why the triangles are congruent or not. So using one of our shortcuts, or we could also conclude that they're not congruent because there's not enough information or it's a false congruency. So first we want to make sure all of the congruent arcs are added to our diagram and tick marks based on the sides. So in this diagram, we have angle E and angle F. So I'm going to place a mark on angle E, place a mark on angle F. We can use one letter for an angle when there's only one angle located there. We have side EH, so that's this piece right here. I'm going to put a congruent tick mark to FH, this piece here. And then we also have angle EGH. So I'm going to trace in a different color maybe from E to G to H. And it's really the angle that's in the middle of that where it would be located. So I'm going to put 2 marks here in EGH, and then we're tracing from F to G to H, and it's the angle at the middle of that it would be congruent to. So now we're looking at, okay, well, why are these triangles congruent? We have an angle here, A for angle. We have an angle here congruent to another angle. We have this side here. Now, when we trace the side, if it's in the middle or connected to both of those angles, it would be in the middle. But if you're noticing, when I'm tracing this side, it does not connect to this angle here at the top. So this shortcut here would be an angle side congruency shortcut. We have 2 angles, we have a side that's not in the middle. So go ahead and try this problem here on your own. Add all the congruent information to the diagram, and then determine why are the triangles congruent. Okay, we're going to use this next sets of given information. We have angle BCA. I'm tracing from B to C to A. So it's the angle at the middle of that. That would be like this angle here. We're going to say that's a vertical angle. Then we have DCA, tracing from D to C to A. Angle in the middle would be this angle here. Okay, so we put the first thing there. We also have angle A and E. I'm going to put 2 marks in angle A, 2 marks in angle E. And then we have AC. So this is AC. I'm just going to put a congruent tick mark on AC, and that's equal to EC, congruent tick mark on that as well. Okay, so we have an angle here. We have another angle here. We have a side. So we have 2 angles and a side again. We just want to know, is it the side in the middle? I'm going to trace the side. Now, when I trace that side, the whole thing, if it connects to or touches the angle markings, it's going to be in the middle. So this one, it does. It connects to this angle here. It connects to this angle here. So we would say that that is in the middle. So the congruency shortcut for that one is going to be angle, side angle. The side is in between or in the middle. Okay, go ahead and answer the question below here. And now, after you've added the given information, state why the triangles are congruent or not congruent. Okay, let's try this third one together. We have QPS, so again, tracing from Q to P to S. It's the angle at the middle, P being the vertex. I'm going to put a mark here. Then we're tracing from R to P to S. I'm sorry, R to S to P, S being in the middle. So I'm going to put a mark on angle S, RSP. And then we have some sides that are equal, QP. So I'm going to trace QP. This is QP, PQ, and is congruent to RS. That's this space here. I'm going to put a congruent tick mark. And then we have PS, congruent to SP. Now, when a side is congruent to itself, you can say PS is congruent to PS. You can also flip the order that the letters are in. As long as it's the same side, that's considered a reflexive side. So what we have here, this tick mark represents this side length. This tick mark here represents a side length congruent to itself, and this angle marking represents a congruent angle marking. So this, in order for it to be side, angle, side, the angle needs to connect to both sides. So when I look at this angle mark, It does connect to this side here. It does connect to this side here. It's in the middle. So this would be a side angle side triangle congruency for why they're congruent. Okay, go ahead and try this third one here. Add all of the marks onto your diagram. And now state why the triangles are congruent. Okay, the fourth one here. We actually don't have all congruent information. This one's a little different. I wanted to practice this symbol here. Maybe write this down, a little note to yourself. What does that mean, that upside down T? That means perpendicular. And that means you're creating a right angle. So on my diagram, I'm going to put a little right angle mark here. So that means that those triangles are right triangles. It also means that those angles are the same. They're congruent to each other. And then I have side length AB. That's congruent to side length CB. So this is AB with the 1 mark on it. And then we also have CB with 1 mark on it. And then we have AD. Put a mark here from A to D, congruent to CD. Put 2 marks on it here. Okay, so now when we're looking at this, technically this is a side that's marked, this is a side that's marked, and this is an angle. Now here's where we need to make sure we check if the angle is in between. Now this angle is not in the middle of the 2 sides that I just marked. It is actually outside. So if I were to write it, it'd be side-side angle, which does not prove congruency. However, this is a special type of triangle. This is a right triangle. And when you have a right triangle, you always want to check, well, could it be hypotenuse leg? And this side technically is a hypotenuse in the right triangle. That's an H for hypotenuse. And this side here is a leg. So these triangles are congruent because of hypotenuse leg congruency. Okay, go ahead and try this fourth one on your own here. And then add your reasoning down below. Okay, and then our last one here, we're going to put a mark on PRQ. It's the angle that's at the middle of that. R being the vertex. We have an angle at SRT, R in the middle, the vertex angle. We have segment PR. And we can trace the whole thing, PR, put a mark on it, trace the whole thing, SR, put a mark on it, and then we have the length PQ. Here's PQ. I'm going to put 2 marks on it, and here's ST. I'll put 2 marks on it. Okay, so what we have here, this 2 marks is a side, this mark here is a side, and this one is an angle, and the angle is not in the middle. Okay, if I were to trace this angle, it's these 2 sides that it would be in the middle of. So it is not in the middle. This would be the middle angle of the sides. So this one is a side-side angle. Again, kind of like this previous one. However, this one is not a right triangle, so I can't check for hypotenuse leg. So for this one, we would say not congruent. And we would say it's not congruent because side-side angle is a false shortcut that does not prove congruency. Okay, so go ahead and try this last one on your own here. And state why these triangles are congruent. Okay. In the second set here, we're going to do a few of these on our own, and I'm going to have you try some independently. Okay, so in our first diagram, all the information is given for us, so we're not having to add it. But what we do need to add is any side that's reflexive or anything that's vertical. So reflexive sides or vertical angles. So let's just take a moment to look back at our toolkit. When we look at reflexive sides, so reasons why sides are congruent. Now, reflexive is one of those things where it's congruent without needing additional information to show that it's congruent. So I don't need a given statement. I don't need to tell you I have a bisector or a midpoint. We should just be able to say, oh, if there's a triangle pair and they share a common side with each other, that should be equal. Okay. So in our diagram here, we should be looking for any sets of triangles where they have a side that's overlapped. That's the same exact side in both triangles. So like I can add a mark here. I'd recommend going through the diagram and figuring out, okay, where are the other reflexive triangles in this set of diagrams? I'm going to, yeah, okay. So just add those for now. And then we're going to go look ahead and look at vertical angles. So if we scroll down to our reasons angles are congruent, we've got vertical. So remember vertical, these angles here, it's really anytime you see like an X, it's these angles opposite to each other. So anytime you see the X's, or anytime, I like to also call them my bow tie angles. So anytime you see triangles that kind of resemble a bow tie, and it doesn't have to be a perfect bow tie, it could be like slightly slanted type of bow tie, but really what you're looking for is that X. So let's see if we can find some in any diagrams here. So it looks like they're really the only one would be these sets here. These could be vertical to each other. So now let's try a few on our own together, and then I'm going to have you try some independently. Okay. So in our first diagram here, we have a side. Here's another side, and then here's this angle. That angle is not in the middle of the sides. Okay. So we could say like side angle, and we say, well, that doesn't work. That doesn't prove congruency. So I want you to decide, are these not congruent, or could they be congruent based on some other reason? And I'm going to take the marks or the writing there. So I'm going to give you two options, HL congruent or not congruent for this one. Okay, let's try the one right next to it. So we have here an angle mark congruent to another angle. We have an angle mark congruent to another angle, and then we have this side. Now, as I'm tracing this side, it's not in the middle. So go ahead and state why these triangles here are congruent. Okay, on to the third question. We have an angle marked up with angle K. Okay, those are congruent. Another angle, we have this side here. Here's an angle. Here's this side, and here's this angle. So go ahead and determine why these triangles are congruent. Here we've got an angle marking that we can mark up here. This is a representative of a side. This is representative of a side. So go ahead and state why the triangles are congruent or not. Okay, if we're using our vertical angles here, we also have these arrows, and actually I didn't realize there was more things that we should be adding to our diagram. When we have those arrows represent parallel. So we actually need to add this to our diagram. I'm going to trace these parallel lines, and I'm going to connect them. And technically you can connect them with either one of the lines, but let's connect them like I've just connected here. I'd like for you to tell me what angle is congruent to angle B because of the alternate interior angles. Okay. And then now, based on what we just provided on the diagram, why are the triangles congruent? Okay, provide the triangle congruency reason here. Provide the triangle congruency reason here. And provide the triangle congruency reason here and for the last one. Okay, now we're going to be looking at reasons why sides are congruent and reasons why angles are congruent. Good places to kind of continually look in your toolkit. So reasons why angles are congruent, and you'll notice here, reasons why angles are congruent, the only type, and I guess I can leave that on there, the only type of angles that are congruent without an additional arrow coming above that is when it's given, a reflexive, or when they're vertical. So we're going to look here, and we've got angle CAT already listed, C-A-T. So that's this angle here. Oh, that looks like an X. That looks like bow tie angles. So go ahead and complete this statement. What is angle CAT congruent to? And then why are those angles congruent? Okay, great. Yes, it was congruent to angle DAB, and that's because they're vertical. All right, and the next one we have our parallel lines. Go ahead and trace your parallel lines, kind of like bold them out just a little bit. We've got MA. Remember this symbol here means parallel. Write that down if you don't know that already. And TN, this line here. So these two lines are parallel. So we're either trying to create, let's look at our toolkit again. we are trying to create with parallel lines, we're either trying to create our corresponding angles. Corresponding angles kind of make that F shape, angles in the F shape. So you can see kind of how I'm creating the F shape there, sideways F. Or my parallel lines make that almost like a Z shape. It could be a backward Z, sideways Z, and it's the angles inside the Z's that we're looking for. So parallel lines lead to those two angle relationships. So I just traced my parallel lines. I'm connecting them. And I've got angle MAN, M-A-N. Go ahead and state the angle that that's congruent to. And give the reason. Great. MAN would be TNA. And that's because they're alternate interior. We had parallel lines that led us to know that was given, that gave us angles that were congruent. Okay, now we have a bisector of an angle. So we can bisect angles and we can bisect sides. So when we bisect, we cut into two equal parts. So this is a given. It should actually just say it on the line. So this is a given information. I don't have to rewrite that there. That is leading us to know. So we're bisecting angle CAN. This angle here is being cut in half into two equal parts. So one part is angle CAB. Go ahead and name the angle that it's congruent to and give the reason. Okay, it is congruent to NAB. And that is because it is a bisector. You can say definition of bisector. If I said I bisected something, I made two things equal based on its definition. Now let's look at some reasons why sides are congruent. So looking back on our sides on our toolkit, sides are congruent. We could say it's given, reflexive, if we have a midpoint or bisector. We have to be told that though, if we have a midpoint or bisector. So this side here, XO, go ahead and state what it's congruent to and give the reason. Good, it's congruent to XO because of the reflexive property. Add your tick mark here if you haven't already. We also have a midpoint. When you're a midpoint, you're a point that's in the middle making two things equal. You're a midpoint of TY. That makes TO congruent to. State what TO is congruent to and state why. TO would be congruent to YO, and I like putting it in the same order. Y matches with T, O matches with O, so I'm putting in the same order, make sure it's marked there. The reason is because we have a midpoint. It says we have a midpoint. What that means to be a midpoint is that you're making things equal. And our last one is that we're bisecting. Bisect means to cut into two equal parts. So we can bisect an angle, we can bisect a segment. So if we're bisecting, this is the thing that's being bisected, X, Y, is being cut in half by the other line. Okay, so if we're cutting that line in half, that's our given information. That makes XV, I'm going to mark up XV, this is one part, equal to, state the part that it's equal to, and give the reason why. Okay, good, it would be YV, and that's definition of bisector. If it says we are bisecting something, that means we're making two things equal. So we're just using our vocabulary from the problem. Okay, now we're going to put all of this information together. We're going to put given information onto a diagram, and then we're going to be stating why the triangles are congruent. So we have right triangles here. So that means I'm going to put my right angles, that's given information, onto the diagram. F is a midpoint of DG. So if it's a midpoint of DG, state what DF is congruent to. Add that to your diagram. And then we have DE congruent to GH. That's given information there. Okay, so go ahead and state why these triangles are congruent. Okay, the next one we have a bisector. We're bisecting WXY, WXY. So we're cutting this angle at the top in half, the angle X. We're making that into two equal angles. Okay, so I'm going to put a congruent mark there. We also have WX. This is WX, congruent to XY. And you should also have another side that's equal to itself. So add the mark on your diagram for that, and now go ahead and state why these triangles are congruent. Okay, in our next diagram, C is a midpoint, and it's a midpoint of AE, so you can trace out that line. What is a C congruent to because of that? You can add that to your diagram. And then we also have some parallel lines. So when we have parallel lines, I'm going to trace them. I'm actually going to get rid of that line there, just so we're not confused. I'm going to trace AB. I'm going to trace DB or DE. And I'm going to connect them with this transversal here. Okay, and let's make angle B. Go ahead and mark up what angle B would be congruent to. Okay, now let's try this. We have AB parallel to DE. Again, this time I'm going to connect them and make a different Z shape. And let's see if I can kind of move that Z shape out of the diagram so you can see it a little bit more clearly. So here's the Z shape I just created. And so there's technically two Z's. And so that's this angle A. Go ahead and label angle A. What would that be congruent to? And I'm going to kind of move the other Z shape out of there so you can see that more clearly too. Let's see. No, I moved it out and then I moved this out. So now you should kind of be able to see, oh, I can technically make two sets of angles congruent in this diagram. So what angle would be congruent to angle B? What angle would be congruent to angle A? And let's use that markings on the markings that we have in our diagram to determine why these triangles are congruent. Okay, we are bisecting something. We're bisecting EF. Here's EF. Go ahead and state the parts that are equal because of that. EH is congruent to. And then we also have a right angle, perpendicular. Add that to your diagram. And then you have another side that would be congruent. So add that to your diagram as well, and go ahead and now state why these triangles are congruent. Okay, our given information in the next diagram is these arrows. These arrows and then some congruent symbols. Arrows equal parallel. And remember, when we have parallel lines, we trace them and we connect them, and they're either making the F or Z shape. So if I trace those and connect them, and then I kind of move it, and you could use patty paper for this too, it's a little easier to see, oh, where are the angles that would be equal because of that? And it's these angles here in that little F shape that would be congruent to each other. So I've just added them to the diagram. We have the sides that are marked there. Go ahead and state why these triangles are congruent. Okay, and here we have all the information on the diagram in addition to this side here being equal to itself. State why these triangles are congruent. Okay, and we have some parallel lines. This should be like a little just line over that and over that. So we have PR. So this time PR, I'm going to trace PR, and it's parallel to SQ. I'm going to connect them, and I made a Z shape. I'm going to move that Z shape kind of out, and you again do that with your patty paper. And then you can see, okay, it's the angles inside the Z, and I kind of didn't fully connect that. Angles inside the Z that would be equal to each other. So again, if I trace that on my shape, it looks like these two sides here being connected here. And so the angles would be located here. that are congruent to each other. Now we also have Q, P, S, put double marks on that. That would be congruent to R, S, P. You can put double marks on that. And then use any other additional information that you can add to the diagram based on what you have, and go ahead and state why they're congruent. Okay, now our last one here, we have this side, and we have LN. And so LN is this whole thing. So really what we're looking at is this whole entire triangle that I just kind of traced out. So we're going to have some overlapping things here. So if I take this triangle out, this is the triangle that I'm referencing. This is LO. This is LN. Now let's compare it to the other triangle here. It would be compared to this triangle. So there are actually some overlapping things, and you just want to make sure we know the pieces that we're referencing. So this side is MN. You can kind of move this out of the shape. There we go. We know that LN is congruent to MO. Well, this is M, this is N, this is O, so MO. And then they actually both have this side in common, ON and NO. I'm going to put 3 marks on that. So 1, 2, 3, 1, 2, 3. So go ahead and state why these triangles are congruent. All right, in our diagrams here, we have these 2 triangles. They're congruent because of their sides. We have all the sides marked on all of them. Now that we know those sides are equal, we should also therefore be able to prove that their parts are equal. So based on C, P, C, T, C. So go ahead and tell me, what does that stand for? Okay, and then because of CPCTC, what is angle A congruent to? What is angle B congruent to? And what is angle C congruent to? Okay, and we're going to finish with some flowcharts. So in a flowchart, we're going to add some information to our diagram. In the center of our flowchart is where I always add congruent symbols. So go ahead and start with that. Congruent, congruent, congruent. Okay. Now we need congruent sides or angles. So remember, if we look at like our little flowchart helper, we know that this like part of the center is going to be congruent statements, right? Congruent statements. So now we're going to go back and we're going to look at, okay, well, what is my given information? We're going to have one given here leading to something else. Let's do one given in the middle. So now I'd like for you to tell me what goes into this given here, the first given. Okay, and because it's B is the midpoint, and I'm going to abbreviate midpoint of AC. That goes there because it doesn't say congruent, but it leads to things being congruent. So B is the midpoint of AC. That means AB is congruent to. Complete this statement and give the reason. Great, it's congruent to CB, and that's because of the midpoint, definition of midpoint. Okay. The other given information, well, that's just right here in the given. I'm going to add that here. AD is congruent to CD. Okay. And then we need one more piece of information. Let's put AD and CD on our diagram. I'm going to do DB. What is DB congruent to? And why? And now we're on our last step. We have ADB. Why are these triangles now congruent? So ABD congruent to, this is, I'm just copying it from here, what we're trying to prove, triangle CBD. And go ahead and state the triangle congruency reason here. Okay, and our last flowchart. So we've got lots of boxes here. I know these arrows are going to lead to something being equal. I know these middle boxes are going to have some congruent symbols in them. And so if I look at them, this says parallel, this says parallel. This is the only one that says congruent. So go ahead and fill in this box here. Great. You put QS is congruent to SU. That's given. QS, that's this segment here. SU, that's this segment here. Now my other givens, they're just going to go here. And it doesn't really matter the order that I put it in. I'm just going to do the first one first. QR is parallel to ST. Now I'm going to trace QR. Here's ST. I'm going to connect them with the transversal. Okay, let's make this a little cleaner. Here's QR, here's ST, and I'm connecting them with the transversal. I'm going to move that so you can see it a little more closely. Oh, and then let's do it in a different color actually. So I can move it and you can see it a little more closely. So QR, this line being parallel to this line. If you want to, you can add parallel markings to the diagram. So I can add like a little parallel arrow. Okay. Now those two angles are congruent, or those two lines are parallel. And what that does is it creates these angles in the F shape that are corresponding and going to be equal. So I'm going to use 3 letters to name these angles just since you're going to have to in some of the other ones. So I'm going to call this angle RQS. Okay, go ahead and state the angle that it's congruent to. Okay, and give the reason. And then let's look at our other set of lines. We have line RS parallel to TU. That's our given. So let's trace RS now, and let's trace TU. Let's connect them with the transversal. And I'm going to just kind of draw that off to the side separately. I'm going to do that in a different color just so we can see that. And if you want to, when you're tracing those 2 lines, you can go ahead and trace this one here. You can do the arrows, the parallel arrows if you want. So I've got TU and RS. These lines are parallel this time. So when I move this, and we've got our, double parallel lines, so we can do 2 parallel lines here. We've got our angles inside the F shape that would be equal to each other. So I'm going to put this angle mark here, and this one I'm going to call TUS. I know you can call it U, but I'm going to use 3 letters since you have to use 3 letters. So angle TUS, what is that congruent to? And why are they congruent? And then now we are able to say that the triangles are congruent to each other. So I'm going to do a triangle congruency statement. I'm going to do triangle TUS is congruent to, if I start with T, I go to U to S, that would be triangle RSQ. Okay, go ahead and state the reason why these triangles are congruent. And the last thing that we are trying to prove, which I don't put this on the diagram, we're trying to prove that QRS, that's this angle here, we're trying to prove it's congruent to STU, that angle on the top. So those angles we want to prove they're congruent after we've proven the triangles are congruent. So these 3 sets of marks here are really the only ones I want to place on the diagram, because if I would have placed these on the diagram originally, it might have confused me for the triangle congruency reason. Okay, but guess what? Now that we proved those triangles are the same, I can say those angles are equal because corresponding parts of congruent triangles are congruent. Let me zoom out one more. So we can be able to say that angle QRS is congruent to angle STU. Okay, and go ahead and give the reason.